Hi guys, wanted to get the screencast out here to finish up the problem we started in class, finding the potential at A for a conical surface whose vertex sits at A, whose vertex sits at the origin. This was the route we chose to go, the defining equation for potential written in terms of the source. Sigma, the pieces of the integrand sigma was given as sigma naught. Script r we had determined was going to be r prime equal to negative r prime, simply because little r is at the origin 0, and dA we haven't yet defined. As we look at our dA, the obvious choice for this integration seems to be cylindrical coordinates. So the dA will be located by an S and a Z. And so the sides of dA, to calculate the area, well, this side is going to have length S d phi. This side is going to have length dr prime. We can't write it as dz. We can't write it as a d phi or a ds. We have to define it in terms of our variables, keeping in mind that we're on the line that defines this conical surface in cross-section. And so as we look at this, we can see it's, according to the problem, it's as high as it is, its height's equivalent to its radius. And so r prime is certainly going to be equal to s squared plus z squared, but s is going to be equal to z. So I can replace either s or z. We can see, again, s is equal to z. And so r prime is going to be equal to root 2 z, or root 2s. If you want to keep it in terms of s, have at it. What that means is dr prime is going to be equal to root 2 dz. And so our dA becomes root 2 z d phi dz, and script r is going to be equal to root 2 z. If we now take all of that information, plug it into this formula, which has mysteriously now picked up the 1 over 4 pi epsilon naught, this is what we get. That's just plugging our information back in here. This is the fill in the blanks exercise. Conveniently, the root 2 z's cancel out. This is not a dz, it's a root 2 z. So the root 2 z's cancel out, and we're left with this integral where phi is going to run from 0 to 2 pi, and z is going to run from 0 to h. And so if we carry out that integral, we do it properly, we will get sigma h over 2 epsilon naught for the potential at A. So we've got to do a similar thing to get the potential at B. The tricky part there is our r prime, or I'm sorry, our script r is going to run from here to here. And so it's not going to be as convenient as it was over here, but it's the principle is going to remain the same. Define each one of these in terms of the variables of integration. Make sure that you specify through the relationship between s and z that you're on this surface, and carry out the integral.